Thank you, Libby. Libby is one of those illustrators you just mentioned. So thanks for having me. Thank you for the invitation to speak. Also, just a little bit about me. Like I said, that kind of describes me. That picture was taken by one of my students in one of my lectures. But yes, I'm one of the anatomists. There are roughly, it depends on the course, but there's roughly 5 or 6 anatomists in each of our courses that we teach, so they're team taught. And this year I had really the joy of being the team leader of the anatomists for multiple courses. So that all happened this year, and we teach in a systems-based curriculum. So we start off with musculoskeletal, we go through the cardiovascular system, we go GI, all the way through. I could go on. We have multiple courses that we teach in that way. I've been here at UGA since 2012, so I was kind of homegrown here, and so I've been teaching for 14 years here. So I love it. This is what I love to do. So I got my PhD in comparative biomechanical science here, and here's all the stuff I'm doing. So besides teaching anatomy, I also have some projects I'm working on. I'm collaborating with a human dentist, not a veterinary dentist, looking at the differences between humans and mammals and pathologies that occur. And I'm always interested in finding ways that I can bring more species into what we teach, because historically what we teach is small animal and large animal. When we say small animal, we say dogs. When we say large animal, we say horses and cows. And so I've been slowly bringing in more things like birds and reptiles. That's what I've been doing more recently. But I'll show you some of that today. But I'd like to do more. So we'll see what the future holds. But when we talk about the species that are normally treated here, most of the times it's dogs and cats, horses and cows. But there are some exotics. There's fish, so there's always opportunities for more. So I think that by sprinkling that in, it helps drive curiosity. And I think, unfortunately, many times they tend to ask us, what do we need to know for the exam? And I'm like, well, I hope you're also here to learn and that you're interested. So I try to drive that. But I also am interested in improving effectiveness in teaching and assessments, and I literally was just at a symposium until noon this morning in Lake Lanier. So I'm glad to be here. I'm glad that I'm actually here, and I'm not driving anymore. So, but I'm trying to promote more of this rigorous curriculum and making it more manageable for our students, but and so that they're not feeling the anxiety and the stress that we tend to kind of cause our students to have. So anyway, that's the stuff that I'm interested in and I'm working on, and some of the research I'm doing as well. So this is what makes our students stressed, right? This is all the things, this is just bumps on the bones. And there's all these different names, and they have to know all these things, right? It's craziness. So, like I said, one of the things that I'm doing, I meant to highlight this one, but one of the things I'm doing is I'm trying to create more, we are creating right now with the medical illustrators here at the educational resources, some 3D virtual models that I kind of found that students struggle with. And so I've been meeting with them, and they doing an amazing job. They make a backbone of a model, and then they say, how does this look? And I'll say, most of the time, that looks amazing. And then sometimes like, well, this needs a little tweaking. And so hopefully this time next year, I'll have some of those models I can show off. I don't have any of those this year, unfortunately. But so another slide. Like, this is just one bone, and there's all these terms that they have to know, right? So I would like to, hopefully, these models that we're creating will help to make this seem less. It'll be rotatable models. They'll have little boxes they can click on. It tells them what it is. They can quiz themselves, and it hopefully will help them see what they're learning, more than just having a list of things they have to know. So this is what we do in the vet school. We have learning objectives, so I thought I'd do this for you guys. So hopefully by the end of this, you'll be able to recognize some of the bones. You probably already can recognize some of the bones. I don't know the level of which the knowledge that you have in veterinary anatomy, but hopefully you can recognize the bones. We're going to talk about some features that are similar and things that are different. Talk about joints, flexion and extension, and then how that allows for the function of the limb, and then some of the other specific structures, specialized structures like nails, claws, that kind of stuff. Okay, so we are in the class of Mammalia, right? We are mammals, and what I have seen is that I don't pretend to be an expert in every single species of mammals, right? But I assume, if you talk about the dog and the horse and the cow, their anatomical structures are going to be pretty similar to, say, a giant anteater or something like that, right? Their thoracic limbs are probably going to be pretty similar. They're going to have similar bones, similar muscles, similar structures. So that's what we'll see are those similarities. But then when you get into birds and reptiles, that's where you start to see, because they're so variable, the species that you see within those classes, reptiles especially, there's a huge variety, huge variability, and so I'll show you some of that. All right, so when you talk about bone, I do this in one of our foundations courses. We asked them, okay, we give them whiteboards. We say, all right, draw what do you think a bone looks like? And this is kind of what I expect a lot of people to put. And actually, they knew what I was asking them to do, so they were really drawing really accurate bones. It's oh, dang it. So, but some of them did this, and I was like, yes, this is what I expect that you think bones look like, and actually they look like this, right? So, and this is a human arm, and so they don't see this, but our students see all the other bones, all the other species, and hopefully they start to think this way and not the cartoonish way. When I look at a dog walking by, I'm like, oh, it's a cute dog, and I'm unconsciously visualizing all of their anatomy, which is kind of weird. But when I'm petting a dog, I'm like, oh, look at the tuberosities of it. So this is a really good dog. It's nice in good condition. I can feel its ribs. But I'm hoping that our students end up that way as well. So here's the general bones of the thoracic limb. I might use the word thoracic limb or forelimb interchangeably because it's the same thing. The thorax, obviously, is where your rib cage is, right? And the arm attached to that is the thoracic limb. So in animals, since they walk on all fours, it's the forelimb or the front limb. So sometimes I use those interchangeably. So as you go down, this is from top down: scapula, humerus, radius and ulna. So hopefully all those, does everyone know these bones? Everyone's comfortable with these bones? Okay, all right. I'm sure that y'all have seen a lot of this before. So this is the stuff that we don't really talk about in vet med, right? Because we don't treat humans. But I tell them, use your own body as a cheat sheet, right? So when we're talking about the biceps brachii, for example, and it's the major flexor, one of the major flexors of the elbow. So I'm on the exam, we'll ask them, we'll tag a muscle and say, what's this function on the limb? And they're moving their thumbs around, okay, good. So it's a way for them to visually see the structures and understand it in a real manner. So it's pretty good. So you should know then the bones, you can see the scapula back here, so obviously this is the shoulder joint. So between the humerus and the scapula is the shoulder. Between the humerus, radius, and ulna is the elbow. The wrist, which is also called the carpus, and then the phalangeal joints, right? And so humans, one of the things that's different in humans is that we have collarbones. There are some other mammals that have collarbones, but the ones that typically have the collarbones are the ones like primates who climb, hang, and so it gives more structural support to their shoulder. We're also a little bit more mobile than you'll see in some of the other domestic species. So here's the dog. This is my one of my favorite species, right? It's what I started my anatomical journey, right? Was learning the dog. And, well, I take that back. It was probably like a fetal pig in high school or something. But as far as veterinary anatomy goes, this was my entry point into vet med. But you can see, like, the anatomy is pretty similar when you're talking about the thoracic limb. Scapula, proximally, humerus, radius, ulna, carpus, metacarpal bones, and the digits, right? So the dog is pretty similar to the horse and the cow. It's just scaled a lot smaller, right? And I'll show you that in a second. But as you can see, so they lack a clavicle, so they spend most of their time on all fours, right? And they don't need to reach up and grab and hang on anything, so they don't need that structural support. So I say they don't have clavicles. Depends on who you ask. Sometimes you'll find a tiny little remnant of one, and that's the speck you can see right there in front of the scapula. So sometimes there may be some little mineralized body. But you can see that the function of the limb, the leg said, I don't need that bone, so it's regressed, right? Makes sense. So that's how it's adapted, and it allows for speed for running, and they also walk on their toes. We have different terminology for how we walk, whether on our toes, our feet, so digitigrade, plantigrade, that's on our feet, unguiligrade, that's on the nails, which is what we'll see in the large animals, right? And the dog also has these pads. So the pads are cool because they act as shock absorbers, but they're also how they get the sensory information from the ground. So let's compare that to the large animals. So again, here's another dog leg. Then the horse leg is the one to the left of your screen, and you can see like the bones look very similar until you get to the foot, right? So you might also notice there's some fusion that occurs between the radius and the ulna, right? So you have this bone here, so that's the radius, and here's the ulna. There's some fusion that occurs there, but like from the carpus up is very similar, right? And that's because they're both mammals, they both do similar things, but the horse is even more adapted for speed, and it needs even more of that shock absorption, and that's when you have these carpal bones, and you see they're stacked on top of each other, and then I'm not going to go into detail, but there's also a lot of muscle and ligament attachment on the back of the foot, and that allows for more of that shock absorption, even though it's only walking on one digit, right? So here you can see, again, the dog, horse, and then the bovine limb. Again, it looks very similar. It's just scaled a lot bigger. And instead of one toe, it has two, right? So the idea of that is that, from what I've heard, is that, it's developed two toes. It's not as fast, like it's not built for speed, but it needs a little bit more traction. So it has evolved to have two instead of one for that purpose. They do have some vestigial digits as well, but they're kind of this little grayish bleb right there. Those are the dew claws, which the dog has a dew claw as well. And so we've highlighted the bones here for you, and so you can see how there's a lot of similarities. So you can see there is some fusion as well for the radius and ulna between the horse and the cow as well. Okay? Any questions so far? This is another thing I like to do when I'm teaching. Like, I didn't do this for you guys because it would have been too much, but I try to ask you questions to make sure that you're getting what I want you to get out of it. But I was like, I don't have time. I have 30 minutes, so I'm going to try and keep this within 30 minutes. Okay, so some specialized structures the large animals have are their hooves, which are like, if you think of it, it's like our fingernails. But what's weird about them is that it's completely encasing the distal phalanges, so your distalmost bone of your finger. It's encased in those hooves, right? In the claws they're called claws in the cow, but they're hooves too. So they, again, specialized structures based on the function of the limb. And if you were to cut into this hoof, you'd see on the back of the hoof or on the palmar surface of the hoof, there's a digital cushion in there, And I could spend multiple lectures on just the hoof, especially in the horse, because there's a phrase, no hoof, no horse, right? If there's any pathology with the foot and you can't treat the foot, that horse is unfortunately not meant for this world, right? So if you've heard of laminitis, it's a huge problem in horses. That's where that bone, the distal phalanx in the hoof, rotates and it ends up like perforating through the bottom of the hoof, and it's very painful. The horse can't walk, and unless you catch it early, there's no real fix for that. So unfortunately, that's a very common problem we've seen in horses. So I've put some of the functions there of the specialized structure of the hoof. All right, so I just wanted to compare more things. So, and this is kind of a joke, but you can see how the carpus, I mean, it's got 2 rows of carpal bones, and they're pretty similar. I'm not going to go into those details. I do that with our students. They have to literally number these bones, right? They have to know which ones are fused in which species, which aren't, but I try to make generalities for them, and you can see there's 2 rows of carpal bones in all 3 species. There's just a couple of fusion that's a little bit different. The reason that those bones are important is there's joints between them, muscles attached to different bones, so that's why they're important to know. If you compare a horse foot to your hand or your foot, they're walking on their middle finger. So horses are always they're being rude to you all the time. So anyway, so that's kind of a cool comparative figure that shows how the horse has developed over time to reduce its unnecessary structures built for speed, right? The horse is like one of the ultimate athletes. The only one that's more of an athlete, I would say, are birds, because they can literally fly. So their cardiovascular system is insane. I could tell you about that, but I can't today. So the muscles of the thoracic limb, I just put these pictures up to show you some of these muscles. Anne is working on the thoracic limb model for me. So I have those models I was telling you about. Hopefully, like I said, this time next year, I could have shown you those, and I could rotate it, and I could show you all the different things, but unfortunately, all I have right now are pictures. I do have a little thing I'll show you in a minute that Educational Resources has made, which is pretty cool, that explains how these muscles work, which I also use in my teaching. So you can see there's muscles of the shoulder up here. So the way the muscles work, right, is they cross a joint. All a muscle can do is contract and relax, right? So if these muscles up here pull on the front of the shoulder, they're going to extend the shoulder. I'll talk about this a little bit more too when I'm talking about flexion and extension. But these muscles down here, right? So these are on the back of the leg. If they contract, if those muscles get shorter, they're going to pull on the back of the carpus, and they're going to flex the carpus. This is a very difficult topic that the vet students, it takes them, I mean, I have some students now, first-year students, who still don't completely understand it. And I'm like, IMSK was in the fall. And so I'm still trying to find the most effective ways of explaining this. So it's important, we have to know what the muscles are, where they attach, and if you know that, then you can extrapolate the function they have on the limb. But you have to understand what flexion and extension is, right? So this picture is good because it tells you this is the flexor surface. See, this is the flexor surface. So it's kind of the way that I explain flexion and extension, using your body, right? If you were to flex all of the joints in your arm, you would make it as short as you possibly could, right? It's basically like balling up your body into as small of a thing you can, okay? And then extension's like, I'm gonna reach out and grab something, right? So that's how I explain it. But another way to explain it is that, do you see how the angle of this joint, it's more acute on this side compared to on this side? This is more of an obtuse angle. We're going to use some math terms, right? So if you make this angle, so if there's a muscle that's attaching here, there's a muscle that comes down and attaches here, there actually is one, it's the tricep. If that muscle contracts, and it pulls the scapula down, that's going to flex the shoulder, right? But also, if that muscle contracts and it pulls on this process right here, which is called the olecranon process of the elbow, it's going to pull that, oops, I clicked, sorry. It's going to pull that up, and it's going to extend the elbow because it's making this acute angle larger. Does that make sense? It takes some time. Like sometimes the students have to sit with it. And the other problem is that when you compare the thoracic limb to the hind limb, they're in the opposite directions. So like, sorry guys, they alternate, if that helps you. So you can see like the flexor surface is on the caudal aspect of the shoulder. It's on the cranial aspect of the elbow. It's on the palmar aspect of the carpus, and then it stays palmar on the foot. But if you think about it, like if you compare, again, you compare that to your own hand, I'm flexing my wrists, and then I'm flexing my digits. So that's a way that I try to, again, give them their cheat sheet of their own body. Okay? So I'm going to show you, let me close out of this real quick. This is something that Educational Resources has made for us. It's really cool. That helps me explain this process. So let me make full screen. So you can drag this little thing right here. So right now it's kind of in a normal position, like it's standing. Did you make this, Brad? Nice, good job. So we're gonna flex the limb. Now it could flex more, but for teaching purposes, you can see that we're starting off in a normal standing position, and it's gonna flex its digits, it's gonna flex its carpus, it's flexing its elbow, and it's flexing its shoulder, right? It's making all those joints smaller, those joint angles smaller. Does that make sense to everyone? So then in the opposite, it's going to start in the flex position, and it's the same thing, but all of these lines that you see that are drawn from bone to bone, those are muscles. And so, I mean, I could sit here and tell you what all those are, but I only have 8 more minutes, so I can't do that right now. But this is really cool. It's really good. So I really like these tools that we can use to teach students the function of the limb, because unfortunately, we work with, fortunately but unfortunately, we work with embalmed cadavers, and they don't really move very much. So that's a problem. Present. There we go. So thank you, Brad. This is great. So let's talk about some bird stuff real quick while I have a few more minutes. So the bird, obviously it has wings. So the thoracic limb are the wings, right? And look how different it is. But also look how similar it is. It still has a humerus. It still has a radius and an ulna. It has a reduced number of phalanges, but the bones are still there, right? They're just different shape, different numbers. They do have a different large process here. There is a coracoid process in the mammals, but it's massive in the birds. Why is that, do you think? Well, if you look in this upper picture, you can see the coracoid process. It's going across, the clavicle is going across. So again, they have a developed clavicle like the primates in the description I used earlier. But they're attaching to this really large bone on the midline, which is the sternum. It's called a keel in the birds. And birds are built for flight, right? So they have massive muscle attachment that goes from the sternum and up to those muscles, or up to those bones, excuse me. So it creates this thoracic girdle that these muscles can attach to because they need that rigidity for the muscle attachment to be able to exert all that force up and down, right? So they need extra anchoring locations for their muscles. The other thing that's really cool about bones in birds is that they're not necessarily hollow. They still have some bony struts, as you can see in that image, but they are called pneumatized. So there is some air sacs that extend from within their body cavity into their bones, which makes them lighter, but they're still strong enough for supporting the body. So birds are really cool, and I wish I could go into more time. But they have the specialized structures, which are feathers, right? They need those for flight. So they need that for more than flight, but at least for the thoracic limb, they need them for flight. All right, reptile anatomy. This is where you get into all your crazy differences, right? So there's multiple orders within the class Reptilia, and there's not that many Rhynchocephalia. There's only like 1 or 2 of those, but there's tons of species of snakes. Like, we don't even know how many. There's so many snakes. Turtles and crocodiles. So the crocodilian skeleton, look at that. Isn't that cool? I find all these things fascinating. So for whatever reason, they developed to crawling on their bellies, right? So look at their limbs. They're kind of oddly shaped, but they're the same bones, right? You still have a scapula, you still have a humerus, you still have a radius and ulna, carpal bones and phalanges. So I find this really, really interesting, and it makes sense if you think about evolution and how things have gone one way or the other, but they still need the muscular support for crawling around in their bellies. So it makes sense that since they're crawling around their bellies, their bones are going to be shaped a little bit differently, and they just look funny to me, but they're pretty cool. We have a Komodo dragon skeleton that one of the other anatomists is working on. It's taking her a long time. I'm like, I want you to finish that because it looks so cool. But again, I don't have time to go much further into that. Okay, so snakes, they don't have thoracic limbs, so I can't show you those. But isn't this cool? I just like to show you. Look at all the ribs. Look at all the ribs in the snake. There's tons of them. I go into this more when I do the other anatomy courses like cardiorespiratory, GI, all that. They're so cool. Their organs can move throughout their body cavity. This is not what I'm supposed to be talking about, but it's really cool. Anyway, so turtles, their skeleton is anchored within their shell. Their vertebral column is fused with their shell. Okay, but if you look, they have a similar little shoulder girdle that the bird had, and I think that's just because of how they also crawl on their bellies, but they also have to carry their shell around with them all the time. So again, more muscular attachment so they can crawl around on their bellies and carry the big old shell around on their back. Here's from the ventral view. So they cut this plastron here. That's the ventral part of their shell. They cut it away so you can see it up inside. But here you can see the coracoid and the scapula again. Again, humerus, radius and ulna, and then the carpal bones and phalanges. It's similar, but it looks very different. So I find that fascinating. Specialized structures, they have scales, right, in their skin, on their skin, and it covers their whole body. And it's like armor for them, but also, depending on the species of reptile, it can also be camouflage for them. This is something that clinicians need to know how to deal with, right? Because if they want to do surgery, they need to be able to know, how am I going to cut the scales? How should I deal with the scales? If I need to do an injection, how do I get under the scales? So there are some other exotics there are other exotics courses, and they talk about how to manage all those different things. But those are their specialized structures. So form equals function, like we've talked about. I've mentioned all these different things, but you can like my little icons. So why does this matter? I told you about like reptiles and how that matters. But you need to know our vet students need to know the bones for cases like this. Do you see anything wrong here? I know there's a circle on it. Do you think there's anything wrong here? Actually, that's not necessarily a problem, depending on the age. That could just be a growth plate, or it could be the bone got broken off. So you have to know, right? You have to know the anatomy, you have to know the development, you have to know where things attach. And if the dog's limping and it can't extend its elbow, maybe because the olecranon broke off, which is what that is. There's also a pretty bad fracture of the humerus here. So it's very relevant, right? We don't just go, memorize all these structures, because you have to know them. You have to know them because you need to be able to say, there's a fracture of the humerus, right? And we need to know ways to fix it. Here's the diagnosis, assessment, and then they fix it, right? And I think these are actually cases from our hospital. A friend of mine gave me some of these pictures, but I think, this is a case from the hospital. So Anyway, that was a very quick, look, I got 15 seconds to spare. Very quick rundown of comparative anatomy of the thoracic limb. I wish I had more time than 30 minutes, but anyway. If you have questions, please email me. I think there's another speaker after me, so I would love to answer any questions you might have, and we can go from there. Thank you.